Um, right, so this is Wednesday of week 10, and I'm very happy to present the final part of our automation package, which is about lean management. And I've decided for the first time this year to try and put lean management in the context of automation of construction in general. So we have talked a lot about digitization of the construction world, the automation of systems, and often some of these systems are not the ones that you see on site, but they're the behind the scenes, the back office, the automation of payment systems, paperwork, bureaucracy, these sorts of things. And of course we have the advantage now that we have new technology coming online associated with artificial intelligence and big data. So all of these things are kind of combining together to improve in effectively what is the automation of a process. And so really the best thing for us to do is to think about how other industries have automated in the past and to see what we can learn from them, because construction is always lagging behind a little bit. So I'm going to talk about something called lean management, and I'll give you some background on this as we talk through it. Has anyone heard of lean management before, other than how I've discussed it? Yeah. So I gave a build-up to it in the last lecture when I talked about quality management, and I'll explain why these two subjects are linked together, forever linked together. But I want to understand what the process is and how much good management comes into lean management. So the history of that explains a bit why. Lean management has derived out of weaknesses in the industry. So when the industry was at its absolute lowest point, lean management became a paradigm. And of course, lean construction is something we already know about. It's something that is being done. In fact, this very building was built using part of it off-site and part of it in a factory that's set up, this Explore factory. It's up in Bedfordshire. It's actually set up exclusively for producing things pre-manufactured off-site. And they have set it up with lean principles. It looks like it looks like a gigantic automotive factory with conveyor belts and U-shaped production cells and so forth. So really, it's quite a marvelous facility. We visited 7 or 8 years ago when they had just spent, I think they spent £100 million on it. It was a really big investment by Lang O'Rourke. I'm not sure if it's paying off. The company's still doing pretty well. But anyhow, this is the building that we're sitting in right now. When it was being built, I took this picture. This is the old Darcy building, which had a molded concrete roof on it, filled with asbestos. So actually, we're way at the back here. So this is heading north, right? This direction right here. Anyhow, much of this was actually prefabricated and made off-site, and you can see some of the sections here don't even have scaffolding on it. There were 2 cranes in operation. It was quite an interesting build. It was quite an interesting build to watch, actually. Quite modern, and I think it's where Lang O'Rourke really refined their just-in-time and their off-site manufacturing capabilities. It was quite interesting from us to see it from our point of view. Apparently this was a cement mixer which they used as a secondary source, just in case they had problems with their suppliers and they were receiving materials and they needed concrete mixed up and they couldn't rely on the trucks. There was real limitations for traffic coming into the site, so they had to block off part of the campus in order to get to it. That's sort of one of the issues about just-in-time and lean manufacturing is the site has to be really well organized and set up properly. Now I'll talk a little bit more about this later. And I really wanted to just put the lean manufacturing in the context of the entire digitization, the process of digitization of the built environment. So it links in with smart cities, it links in with artificial intelligence, with big data, with kind of data analytics. robotics and so forth. And in like most things, construction's catching up. I mean, there's always one industry that's going to be way ahead. Certainly electronics, automotive, the silicon, the chip manufacturing is so highly automated right now. There's very few people sort of involved in the actual process itself, and so anyhow, there's a bit of a lag, and that's just the nature of our business. That it's on site, it's not centralized, it's not in some ultra clean facility somewhere. It's out in the open. But anyhow, the other industries can really give us a lot of insight. And I'm particularly keen on lean. The history is quite amazing. And if you don't think it's effective, in other words, if it's one way to lead towards automation. It's not the only way, but it has been the most startlingly effective. So the reason it's been effective is, the reason we know that it's been effective, it's been pioneered by a single Japanese automotive company, Toyota. And they came from being an almost unknown, cheap manufacturer of economic cars into the biggest car manufacturer in the world, so the most profitable car manufacturer in the world. I think they've lost that position slightly in the last few years for a variety of reasons. Mainly because their competitors have adopted lean manufacturing. So they did this from obscurity to the richest in the world in 25 or 30 years. So it's really quite a remarkable feat in manufacturing, and not a feat that can be really ignored. And the story is really wonderful, I mean dramatic. I mean, Japan was blown up, was destroyed by the end of World War II. There was not a single factory left standing, so they had parts of factories, parts of machinery. The workforce was really in terrible shape. People had lost family members and they had lost lives. They were damaged by the war. It was incredible. It was a war, particularly in Japan, where the Allies, the Americans, bombed civilian populations. And the city of Tokyo was firebombed. In 1 or 2 days, there was some 100,000 people killed. And not to mention the nuclear bombs in Hiroshima and Nagasaki. It was devastating what happened. They lost hundreds of thousands of their citizens, and men, women alike. So it was non-discriminatory. So there was very little to start building on. But one thing that was different about the post-war period in Japan is the Japanese, for one reason or another, accepted the help of the conquerors. So instead of an invading army, the Americans, instead of sending soldiers, well, they did send soldiers, but instead of sending lots of soldiers and having an occupational force, they sent statisticians and engineers from the technical universities in America. And so they sent men who understood statistics and process management. And America by then, at that point, was ahead of Japan in terms of industrialization, had a bigger industrial facility. It was more sophisticated, had lots of technical schools, lots of universities, and they had done very well to integrate mathematics into engineering. And this was an important part of the development of lean management. And it set out to begin with as an open system, so there was no point at all keeping it secret. They were too desperate, they were too poor, and they were too busy to catch up. So they had to share, and what they shared was this managerial approach. Lean management does not work in isolation. Your suppliers have to be aware of what you're trying to do, and in a certain respect, your clients, your customers have to be aware that your approach is towards lean management. And I'll give you some examples. I've given you an example already on this particular site with Laing O'Rourke, why the customer needs to be aware, but I'll give you some more examples here. So anyhow, Toyota Motor Corporation became a world leader in 2008. The lean management actually was coined after Toyota adopted it and perfected it. So Toyota doesn't refer to it as lean manufacturing, they call it the Toyota way. So the Toyota Way, that the lean manufacturing was actually coined by authors and secondary writers who spoke about it and wrote about it. And of course it's caught on. No one ignores such a success. And so it's caught on in administrative circles and bureaucracy. There's been attempts to reform the NHS based on lean principles. The idea that you would have all of these processes organized along the same lines that you would a manufacturing. So if you go in to get a bypass, you follow the exact same procedure as you would as anyone else who was getting a bypass. I mean, there are adaptations to the type of body you have and the differences in your blood type and so forth. But it was heavily procedurally based. Didn't work very well, by the way. There was a lot of resistance to it. But you might ask, what is the core thing? If you're going to say one thing about lean, what is it? How do you define it? And what it comes down to it is the systematic and continuous reduction of waste. That doesn't mean the end object was to reduce waste. The end object was to have a more efficient and profitable system. But the way you achieve an efficient and profitable system, manufacturing system, is to systematically reduce waste. It's a little bit of a sidestep. It's like if you want to do really, really well in school, clean your bedroom or make your bed. It's like if you really want to do well in your job, wake up in the morning and have a good breakfast. I mean, it doesn't seem related, but of course it is. And it's that systematic, continuous cycling through, constantly identifying and characterizing and reducing waste. And of course, waste, it's largely understood. Lean management is largely a misunderstood managerial concept. That is because it's associated with something else called Taylorism. Taylorism was a term used to describe mass production using a stopwatch. So the man is treated like a piece of machinery. And Taylor, of course, was some poor guy, and he gets up with this horrible name. He was actually a Quaker. He was very sort of civically minded kind of guy. And he thought that he could improve the lives of workers by systematizing their work life. And I'll explain a little bit what Taylor did. Unfortunately, his name, and he was quite a well-meaning man, his name got associated with something quite negative. So Taylorism is now used in sort of certain political discussions in order to improve, as a bad thing. We don't want to be Taylor. We don't want to end up as being Taylors. Yes?
So could you say that lean management would focus on like you said, it's like the term factory line. They're trying to focus on mass producing everything. Wouldn't you have to sacrifice quality for that?
It's a good question. So the question is, just for those who didn't hear it or for the recording, the question is, isn't lean management all about production and manufacturing on a production line at the sacrifice of everything else? You would think so if you had a superficial view about how the system actually works. But if you look at it from start to finish, you realize that it's an actual focus on quality. And that's why I started these series of lectures with quality first. Because lean management was really an attempt to address quality issues. And as I progress in the lecture, you will understand how quality and lean manufacturing are actually linked. But there's other things which are linked, which is empowerment of the employee. So in order to make lean management work, you have to devolve power down to the level of the operator. So lean management does not work if a human being is just a machine. It works only if the human being is a bit of an engineer, a bit of an economist, who's actually working these things. So in many ways, it improves the work and and if you see it, if you walk through factories where lean manufacturing is practiced, actually they're quite pleasant places. There's less noise, there's less chaos, there isn't as much order in place, they're neater, they're more systematized, there's less movement. And the workers seem quite content. They're making more money, of course. So that's besides the point. But I think your question, which is a good one, will get answered in the course of my lecture. Well, there's always been an equation between time and money, and perhaps more better articulated than Benjamin Franklin, who was one of the early American printers. He was actually a Bostonian, lived in Philadelphia, and he had a printing press on Market Street, just between 5th and 6th, I think it was. And he wrote this. One of the things he printed, and he was more than just a printer. He actually wrote a lot of stuff, and he said. He wrote this thing called Poor Richard's Almanac, which is this sort of guide to how to be an industrious colonial American. And he said that, it's rather wordy, but he said that he has earned 10 shillings in a day by his labor and goes about and sits idle half that day. Although he spends maybe 6 pence during his idleness, he ought to reckon that his own expenses are really spent as ways throwing away 5 shillings. So what he's saying here in this definitely 18th century Americanized English is that time is equal to money. If you don't spend your time industriously, it's as if you're throwing it away. And that's really come down to the essence of what waste is. And of course, in America in those days, it was in Europe also, America industrialized quite early on, just about the same time that Britain did. But what the Americans did much better than the English is they actually wrote about it. And so there was a lot of writings and discussions and literature produced about industrialization, which in Britain it was mostly about labor and being trapped in cities and how badly they were treated. But in America it was really about the success of industrialization and how to actually do it somewhere else. And much of this came about as this attempt to standardize. And I'll get back to post-war Japan, because standardization was absolutely necessary when you have things highly fragmented. So America was spread out pretty much along in those days, the industrial part was spread out along a line of industrial sites along the fall line, so where the water power was, really between kind of Boston down to Baltimore, really. And there were factories pretty much every 20 miles. It was much longer and bigger than the one in England, which is kind of concentrated in the Midlands and bits of London, and well, Oxford was included as well. But anyhow, it was quite a long swath, and it was quite spread out. And essential to this was the idea of interchangeable parts. So you could make parts in one place that could be assembled and used in another, or you could have multiple sources. If one part producer failed, you could simply order another one. And this became a real imperative during wartime, when bringing weapons into battle with you. You had to make sure that they were interchangeable. And there was this sort of distinction made between the British and the American style of manufacturing. There was distinctions made from the very early days about this obsession with standardization. In fact, the British Standards Institute is a quaint building in London. The American Institute, or the American Standards, it's a Bureau of Standards in Gaithersburg, Maryland. It's this huge plant. It's an enormous campus. It's like a big university. There's thousands of people working there. And I think that's kind of the distinction, this centralization of standards. I'll mention more about this later, because the lack of standards can actually cause more problems than it's a lot of work to produce standards. Right now we're held up, the BIM seems to be held up, blocked a little bit because of the lack of standards. So BIM level 2, we probably have the standards in place to do BIM, but BIM level 3 is being held up because we don't have a standard way of interacting with each other in a shared model. So using a shared model contributed by dozens of people, there's no way to separate out the contributions. There's no standardized way of approaching a shared model. So the lack of standards is actually quite difficult to implement in a digital world. But the advantages for the arms industry was incredible, and the ability to manipulate and to move materials and men into battle using standardized parts was a great achievement. And you could win battle with inferior equipment as long as it was replaceable, repairable in the field. And Samuel Colt, this famous American originator who invented the revolver, he was the first one to patent a revolver that was mass produced. It was an incredibly simple device, but it could be made anywhere. In fact, they were made in backwoods, and they were easily made just using standard measurement devices as well. So anyhow, what I hope to get out of this sort of learning objectives here, I've given you a bit of a preamble, was to understand the basic elements of lean management and how they're linked in with quality, which I've discussed in the last, and how, of course, this applies to the built environment and particularly to the automation and digitization of the built environment, which are the things that we're really interested in. And then I'm going to try my best to link things like process innovation, quality management, environmental control, and to get a little bit practical here, to understand what the tools, the various components of lean management are, so that you can go off and one day implement it yourself. One day be able to know what to do when you're faced with the task of improving the process and performance. So the first things we realize in the Japanese approach to things is they highly formalize their definition and their approach to waste. So like everything else, they name it, they categorize it, they expanded it. They really focused on waste. They realized that by focusing on waste, which seems tangential to what they were doing, they were actually focusing on something that eventually would lead to greater production and greater profits. That's what they really were after. And I think it's hard to picture now, because Japan is seen as they produce these amazing cameras, and so much of this equipment around us is Japan, so much of automotive and leading automotive. But at the very beginning, they were making cheap stuff, cheap goods. And I went to see a lecture by the guy who founded Sony, and this was maybe 25 or 30 years ago. He was an old man by then. I can't remember, he was called Akira Morito, I think his name was. But anyhow, he gave a lecture at the University of Pennsylvania, and I came out to watch him as a student at the time. And he took out this little umbrella, this little paper umbrella that you put into drinks, and he said, when I was a young engineer, I sat around the table with some Germans after the war, and they were helping with the reindustrialization of Japan. And one of them pulled out this little umbrella, and he said to me, "This is what you make in your country. This is what you do. You make this little umbrella." And he said he was so horrified by this description of his country that he was determined to actually prove it to them. And I think he did in so many ways. Sony, certainly one of the most amazing companies really ever to have existed on Earth, and to have produced such a range of goods and invented so many things. I think he proved his critics. So anyhow, the idea behind categorization of waste is really critical to lean management. And I'll go through these in some detail. I have a feeling this lecture is going to span 2 periods, because I don't think I can continue to speak for more than 55 minutes, but I'll do my best. And we have time next week to do this properly, and I think it'd be useful. It'll give you a chance. It'll give you a chance to go back and do some of the background reading, because the reading and the books written about this subject are equally as amazing. We have everything up to date in the library. I have uploaded stuff into the reading folder. Whenever I come upon a new article about lean construction, lean management, I tend to post it that we have access to. So it'll give you a chance to do a bit of the background reading on it. I think it will help you to catch up on the subject. There's a lot of new concepts. Things are a little bit unusual here. So anyhow, there's the waste of overproduction. And you might think, well, overproduction's good. I have more time on my hands. I have lots of material. Why don't I just overproduce? And if you overproduce, you create waste. You create waste of goods lying around. You create the waste of someone having to move stuff. You create the waste of time you could have been doing something more useful. So it's this overproduction that's seen as a bad thing, and you have to constantly ensure that there isn't overproduction in your system. The problem with the overproduction in the waste of waiting. For everyone that's overproducing, there's someone else who's waiting. In other words, if you're waiting for raw materials to be delivered to your station, if you're waiting for a work in progress to be delivered to where you're working, if you're trying to apply and finish a work but you have to wait for it, or if the electricity is off, or if the machine is down, there's associated cost with waiting. There's waste in the system by underutilized human activity. Waste of transportation, shifting stuff around. Transportation is essential. Logistics and transportation are fundamental to any kind of manufacturing process. Projects often succeed or fail based on the logistics. And construction projects, one of the first things you do is sort out how you're going to get the materials and the goods, how you're going to stage them, where you're going to host them, how you're going to lift them on site. So transportation is actually absolutely crucial. But if you over-transport, in other words, if you make it more difficult, if you're doing pre-assembly on one end of the country, post-assembly on another, and try and work it all together, you end up with an overly complex transport network in place. In exactly the same way, if you have a factory floor where materials cutting across it, we have the entrance door on one side, the assembly room on the third, the paint room's on the fourth. You're moving the same material back and forth and back and forth. It's much better to set up a flow. And that seems logical, but many people don't do it. Many factories don't actually have it. Well, let's just talk about that as a systematic. Someone is responsible for dealing with waste and transportation. They look through the material flow. Where is the material coming in as it moves through the factory, as it's ordered in? Excessive inventory. You might think having excessive inventory is a good thing. It's slack, in case we have an extra demand. But actually, you really want to keep a minimum of inventory. Now, we'll talk about this because it's one of the paradoxes of lean management. Someone's got to hold excess inventory somewhere. Somewhere along the supply chain, someone's got to be holding stuff. Otherwise, other people can't be lean. So the whole system itself, often it doesn't function very well if it's completely lean. I'll give you some examples of that in a little while. But work in progress, raw material, excessive material, stuff that you half work and you store, the stations that you put it in, it takes up space, and there's money wrapped up to them. For every unfinished part, you have a part that hasn't been sold, that money is not in the bank. The real trick in this is to get from the time of your orders to the time of your delivery, and the money is in the bank, is to shorten that time as much as possible. So it's really the excessive inventory. And when you do an inspection, and I've done a few of these on lean factories, you go around and look at the labels of materials. So you see a roll of sheet metal, you look at the label, when was it delivered, when was it produced? And if it's a year or two old, you realize it's been sitting there rusting in place, hardening, whatever, aging, when it should be, and there's money wrapped up in a big roll of steel could be several $1,000s or dollars. So it's like getting stuff through the system as quickly as possible in order to really squeeze out that excess waste. Over-processing. Often components are over-managed, over-designed, over-engineered. It's excessive. They have to be rethought about how the process is done. Maybe one machine process could do the same job. Maybe there's a way to simplify it. Often administrative aspects are done with duplication, triplication. Someone has to sign it. Someone has to double sign it, has to go back, has to be printed out. So it's not just the manufacturing, but it's the back office stuff that can't be over-processed. Wasted motion. This has to do with individual employees and their activities at work. When you walk into a lean manufacturing center, you don't see people running around. You don't see excessive motion. You see choreographed action. People are taking small but concerted steps. Their body movements is actually managed and considered carefully so that they don't put strain on themselves. And then you have lean engineers going around checking people, lean teams going around looking at people for their movements, how far they have to go to pick a part up, what kind of tools, what kind of aids there are in place to make sure that they have ease of access, ease of assembly. And this is where the operator comes in. The operator knows best about his individual movements. He's trained to understand what ergonomics is all about. So there's ergonomic engineers which say you have to put a part underneath a piece of machinery. Well, you need to design a special cart to go on, has wheels on it to lift you down so you can lay yourself down underneath it, or maybe a special kind of fork that holds it underneath. There's all sorts of clever ways to do difficult procedures, but it takes the engagement of the operator to reduce the waste of motion. Rejects. So defaced and rejects can actually, so a reject is a part that you come to the end, it's been assembled, it's done, and it doesn't work. It's flawed, it doesn't reach the study. It has to be some way of dealing with that. If you throw it away, you're going to throw away all that effort, and that's certainly waste. And the waste of defects actually is so important that there's a whole science associated with it. And so you could either repair it, you could replace it, you need to inspect it. So there's a whole science involved with dealing with defects and rejects. And if you examine things like the microprocessor industry, they've got defect management down to an absolute science, because you're dealing with not parts per million, but parts per trillion. They're actually dealing in such fine detail, such high precision. Because if you put together a 500 or 600 pound computer chip as one tiny little defect in it, the whole thing is useless. So their way of dealing with it is incredible. The waste of non-production time. Non-production time is when one team is working really fast and the other team has to slow down, because you don't want overproduction, you don't want excessive stock building up, you want to have everyone balanced and matched. So one team is working fast, the other team is working slow, and you waste time in non-productive time. So non-productive time would be sort of, I don't know, tidying up your workstation or rearranging the furniture, some other. You have to be adding value at all moments, adding value to a part that's going to be sold to a customer. I think, and this is one that I've added on, which is underused employee creativity. If you don't exploit your most valuable resource, in all of lean manufacturing, it's always the brains that's the most important, the people who are manipulating, coordinating all this activity. And if you don't actually make use of them, if you ignore their advice or don't allow them to express their creativity, the people actually touching it and handling this stuff are often the experts at it. Might not be a particularly glamorous job, but they're the ones who are doing it day in, day out. They actually have something to contribute, and they should, and often it's the same, improving their quality of life or their work-life balance or whatever. It actually improves the product as well. Now I'm going to introduce this concept of Kaizen, because it is universal, it's ubiquitous. You hear about it in every industry. Everyone talks about it. So if you go up to the Cowley plant, and I highly recommend you take a visit there, it's right nearby, and they're right at the cutting edge of automation in the manufacturing of cars. It's possibly one of the best plants in Europe, really, right now. They're making really fabulous, expensive motor cars. They're so expensive, people living around here can't actually afford them. But I would recommend taking a visit. It doesn't cost much, well worth the afternoon. And they'll talk to you when they give the tour. They'll use these Japanese terms, which I'll mention to you now, and you can ask them about it because everyone in the factory would know about it. And the basic principle is this kaizen, which is continuous improvement. And the idea, continuous improvement based on knowledge. So it's an intelligent kind of reevaluation of what you're doing and a rethinking of how you can improve it on every stage. So it's a cyclical, continuous, and ongoing process. So if you had a very efficiently run lean system and you kind of didn't manage it, didn't continuously keep it, it would eventually degrade. One part would go bad, and then another part would go bad, and then eventually sort of slowly start to be off lean. So lean is more of an aspiration than an actual, once it's lean, it's certainly not a stable state. And this is one of the problems that, and there are other problems that come in. Toyota was very briefly the biggest car manufacturer in the world, but it didn't stay that way long, and it's because other problems crept into their business. They had a problem that just would not go away with one of their most popular models, and it affected their sales terribly, and had to recall hundreds of thousands of cars. It was a mixture of design and manufacturing error. So they couldn't quite get to the bottom of this, kept on trying to fix it, and it was lasted 3 or 4 years before they finally resolved it, cleared it out of the system. But anyhow, when something like that happens, and this is the approach that Toyota took, is that they really focus on stakeholder satisfaction. So are your workers happy? Are your shareholders happy? Are your suppliers happy? Most of all, are your customers happy? And you have to come up with a way to stabilize the system, to make the system, you might still have errors in the system or problems, but you have to stabilize the production so you can actually see what's going on. And you have to be able to sustain it. So there has to be some momentum in place, a managerial momentum, to instruct people to maintain it. And of course, quality is, as mentioned in last lecture, is always the primary. If quality isn't up to scratch, then you're going to get rejects and returns, and your stakeholders, your customers aren't going to be, your employees are going to be unhappy to have to deal with all these. And then of course on-time delivery, getting your timekeeping correct. So all of these things sort of work in a cycle of this sort. You'll see different depictions of this, but different depictions of this Kaizen process. It's always in a cycle. But I've rephrased it on this because I think this is sort of the most useful way to look at the kind of situations that we will be facing working in construction companies where there's an emphasis on lean construction or an attempt to lean construction. So let's just talk about sort of from the more human point of view what it is to the basic elements of lean manufacturing, and it also has to do with sort of good management, sort of a positive, constructive atmosphere where you're talking about systems. So it's not individuals that are making a mistake; it's a system that's allowing individuals to make repeated mistakes. The system is what the problem is. So if you fix the system, employees won't fall into the trap of doing that. And then this shifting of the responsibility for performance down the organization. So, okay, if the company fails, then the boss should go. But actually what really should happen is the boss should devolve responsibility down to the lowest level of the factory, of the production as possible. And that the focus should be on this creative relationship between machine and cell, machine and manufacturing cell, and the idea of the minimum of capital investment. You think that, okay, we need to throw money on automated machinery. That's not the way it works. You make judicial and very careful investment decisions about cost effectiveness of machinery investments. So it's not just throwing money at the problem. It's actually thoughtful and a calculated investment on new machinery for automation. Here we go. And then that everyone is responsible for cost and delivery. So everyone is engaged with cost. It's actually a transparency about the cost of certain items on the shop floor. So it's not hidden. So you know what the cost is. If there's a defect, a cost of a failed part, a cost of missing a due date or something like that. And that there's sort of total employment involvement. Employees understand how the process works, where the profits are being made, where they're being lost, what the margins are like, what the competitors are doing. So it's a much more informative and engaged process. And that, of course, requires really good communication between operators and management. The best construction sites are the ones you go on and no one's shouting, no one's running around, people are talking to each other, but mostly people are just getting on with their work. They're quite quiet, there's not a lot of things dropping off the scaffolding. It's just, you don't actually see much happening. But of course the building's getting built, it's just they're not making so much fuss about it. Key to this is this idea that you're recognizing, you're rewarding people for what they're doing. And if you do go on sites today, you will see that there's employee of the month, there's recognition, you get cash payments, if rewards if things are done on time or ahead of schedule, so forth. And I added this last one, which is this company-wide understanding of the daily cash position. And one of your tasks in the last coursework was to do a cash flow. And the reason for that is to understand what the monthly cash or the quarterly cash position is of the project. Are we spending a lot of money this month? Are we heading towards breaking even? Are we digging ourselves deeper into a hole? Where are we in terms of the cash in our pockets? Are we running out of our initial money that we borrowed? Are we building up excess? What's going on with cash? And actually that's a company-wide understanding of cash position is essential, and that's really why I said it as part of the last assignment. Right, I am going to stop at this point. I think I've spoken for near 55 minutes non-stop. I think I'm going to take a break, and then next week we're going to come back and finish up this lecture. But meanwhile, I hope you have a chance to read it. I promise that I will issue in the next day or so an FAQ about coursework number 2, which addresses many of your questions, including those that were asked at the beginning of the session today. And I'll also make a commitment to finish the marking by Sunday night, 23:55. Okay, thanks so much. See you next week.